are the areas of focus for us. Just in the last 12 to 15 months, MediaTek has delivered a number of groundbreaking technologies and products into the market. Our Dimensity 9400 Plus, which is our flagship smartphone silicon, really sets us up for an annual cadence of flagship renewal on the smartphones front. With NVIDIA, we have launched DGX Spark, which is sort of this mini supercomputer on your desk that allows you to do a bunch of AI-related workloads, optimizing them and developing them. We have leading technologies, including 224G SerDes, 2.5D and 3D packaging, and a lot of co-development at the design level, at the system technology level with partners to enable leading AI accelerators and technologies from the edge to the cloud. MediaTek is a leadership in connectivity with our cutting-edge modem, satellite connectivity, and now RedCap or reduced capacity coming up. For those in IoT, RedCap is a very welcome development. Think of it as 4G-like speed and capabilities, but very much compatible with the 5G network and therefore future-proof at a much lower cost, because not every IoT device needs gigabytes or gigabits of bandwidth, with the exception of maybe smart video cameras. And finally, our ecosystem is a critical part of why we are successful with partners like NVIDIA, TSMC, lots of partnerships with Google around Android and other areas like Chromebook, ARM, Synopsys, and Cadence, just to name a few. All of this is resulting in SoCs that show up on the edge and eventually in the cloud with devices like cutting-edge smartphones, Chromebooks, IoT devices, automotive experiences, AI supercomputers for cloud developers sitting at your desk, as well as ASIC. Let's turn towards IoT as a strategic focus at MediaTek. The picture you see on the right is our CEO, Dr. Rick Tsai, with Jensen, who's the CEO at NVIDIA. Doesn't really need an introduction. They both spoke at Computex in Taipei earlier this year and highlighted the partnership that spans automotive, client computing, ASIC, and of course, IoT. At the bottom, you can see a comment from Morgan Stanley that talks about the transition to ARM from a CPU perspective and how that's disrupting and transforming multiple markets. And MediaTek is proud to be at the cutting edge of this transformation. So what are the advantages that we bring to IoT market? Like at most IoT companies, IoT silicon companies, IoT at MediaTek is a high leverage business where we look at capabilities in some of our other business units and bring them into the IoT market with the key requirements that IoT has: ruggedization, long life, multi-OS support, and extended temp support. From our leading role as a mobile SoC vendor, we are bringing low power, high performance ARM SoC, great connectivity through cutting edge Wi-Fi, but also optimized for power, 4G and 5G connectivity, and then enabling the Android and Linux operating system on top of it. Our leadership in smart TVs allows us to bring multimedia capabilities to the table, whether it's for human machine interface or applications like digital signage or even projectors in the IoT space. And finally, our investments in AI. We are already on the 8th generation of neural processing unit that was originally created for the mobile space, but now has been adopted into multiple other verticals. Gives us a key advantage as well. Automotive focus brings both requirements from a high quality, ruggedization, and supply longevity perspective, not just on the hardware side, but on the software side. And we'll talk about that a bit more. If you look at our SoC roadmap, there are two distinct buckets we can talk about. MediaTek Genio is really our open platform offering, supporting a very broad ecosystem, a broad set of applications, rich interfaces, and has 10 years or more longevity associated with it. This also allows a third or a slim modem to be attached to it if you need modem as a connectivity, and has support both for Linux and for Android. But that's not all. For the subset of IoT applications where a highly integrated modem-based part is required, we also have the MediaTek IoT modem series that is primarily focused on Android because mobile point of sales devices or applications like fleet telematics tend to be examples of where the device itself is in motion and therefore requires consistent cellular connectivity, and the built-in modem is an advantage in those scenarios. Our IoT SoCs are sold across virtually every vertical you can think about, but here is a subset of the verticals where we are seeing stronger traction and uptake. I talked about smart home, things like home control, SoCs, um, smart appliances, fitness equipment. All of these areas are where our SoCs are being adopted at scale. In terms of smart retail and hospitality, everything from mobile point of sales to desktop point of sales to digital signage, self-checkout kiosks, AIDC, all of these applications and use cases are adopting MediaTek silicon. When it comes to display, I talked about our heritage of driving, millions of smart TVs globally. Those same display capabilities and AV streaming and multimedia capabilities are brought into prosumer audiovisual equipment, IP phones, commercial displays for digital signage, and so on. And finally, on the industrial side, factory automation, intelligent healthcare, and intelligent transportation are some of the subset of use cases and verticals where we see traction. We obviously, through our partners, also support the standardized form factors for easy adoption into the end customer product, whether it's SMARCs, OSMs, or single board computers. So let's turn to the main focus of the conversation today, which is enabling AI use cases. Um, let's start with why do we believe AI adoption, while historically has been focused on training in the cloud, will really be driven by inference at the edge. What we are finding is that um, cloud-only solutions are quite effective at scale, but there is a cost element to that where whoever is utilizing the cloud services is actually paying for that capacity, whereas doing it on your device at the edge makes it more economically feasible. By selectively sending data to the cloud, a perfect example is a video camera that's recording 24/7. It only needs to send data to the cloud if a particular event has occurred in a home context, if there is somebody passing by your house, or somebody is spotted in the vicinity. If it's a traffic camera, then is there an accident or traffic congestion starting to happen, and so on and so forth. And so this ability to infer what's going on at the edge and only selectively send data makes for both better and more efficient data transmission and lower power consumption, which obviously contributes to the sustainability aspect as well. Latency is an obvious one. For use cases like autonomous driving, this has been a requirement. Edge processing has been a requirement from day one, but increasingly in other areas, the reduced latency requirements, industrial automation being another example, are becoming important. Of course, doing analytics and decision-making at the edge of the device is more secure. It addresses the data privacy aspect as well. And finally, our ability to have a better sense of the context in which the user is operating the device helps us enhance local personalization. And these five pillars of edge AI processing, inference, and optimization are applied in all the markets, including in IoT, on our Genio products, for example. So what is it that the end customers are asking for? Because ultimately, it's not about technology, right? It's about what it can help our customers and their end customers do. So everything from data analytics to predictive analytics to actual decision making, personalization, and enhanced security are important aspects of why customers are choosing our platform and working with us. In terms of our silicon roadmap itself, we were very careful to methodically build out a roadmap over the last 8 years and create a sort of a proven platform stack, I call it, uh, so that our customers can design good, better, best versions of their products, starting with Genio 350 at the bottom, 500, 510, and 700 in the middle, and Genio 1200 at the top. And by the way, the middle part of our swim lane is pin compatible. So our customers love the fact that they can do one design and have two levels of performance, and therefore they are able to offer products at two levels of pricing to the end market. The good news is earlier this year, we refreshed the middle part of our swim lane because that's where a lot of customers are asking for more generative AI capabilities. So now you have Genio 520 and 720, which are both pin-to-pin compatible. And these are all supported with Android and on the Linux side, both with Yocto, and we work with Canonical to enable Ubuntu as well. So if you look at 720, and I'm using 720 as a proxy for both 720 and 520, different levels of performance, very similar design. It's an octa-core that gives you two big cores and six small cores. So performance when you need it, efficiency when you don't. Um, LPDDR5 is supported, which was an important aspect when it comes to generative AI applications. Our eighth generation NPU is integrated, provides up to 10 tops just within the NPU. And then you obviously have the GPU and the CPU capabilities as well. Supports 4K and 5K ultra wide display. You can also hook it up to two dual to 2.5K displays. Wi-Fi 6 and 6E baseband is integrated. Camera capabilities, rich interfaces, commercial and industrial SKUs are available, supports OSM designs for compact form factors, and 10-year or more longevity is guaranteed. We very carefully architected this generation of Genio to be GAI capable. A lot of our customers are asking for the ability to run small large language models or small language models as they're called. So we optimize not just in terms of raw tops and the NPU capability, but the kind of memory, which is LPDDR5. And we also expanded the max memory that can be that the design can be populated with to 16 GB. So between these three capabilities, we are able to offer an architecture, a platform that's very much compatible with most of the cutting edge small language models like Llama, the Phi Mini, Gemini's version, DeepSeek, and so on and so forth. It also comes out of the box as, with full support for our NeuroPilot SDK. And I'll talk about our partnership with NVIDIA Tau that enables you to use 100 plus models that are pre-existing today. Finally, we have a dedicated Genio developer portal that I'll talk about a bit more as well. Now, the biggest question that I get from customers is, Samir, how do we get started? So we have created an evaluation kit, an EVK, that gives you a display capability, but also access to all the rich interfaces. And you see, I won't go through the entire list, but you've got different interfaces exposed through the M.2 form slots, USB slots, and so on and so forth. So the entire gamut of these IOs are available to you to test out your workload, to sort of pre-design whatever eventual design you're trying to do and evaluate that workload on our EBK. Software is as important as hardware, and in many ways more important than hardware, which is a strange comment coming from, a silicon company, but we understand the importance of software. So we've made sure that on the Android side, we have 3 Android version upgrades available on these platforms. And even after that, a 3-year security patch available. Similarly, on Linux, 3 kernels and the corresponding upgrades are available. And beyond that, 3 years of security patching. And then on Ubuntu, we follow the standard Ubuntu policy for customer support. And this is supported all across all of our Genio platforms. One of the things we've done in a partnership with NVIDIA is to adopt the NVIDIA TAO toolkit, which stands for Training, Adaptation, and Optimization. Think of it as a single workflow where you can take 100 plus pre-trained models that NVIDIA has developed and then bring them onto our NPU. And so all the training and the optimizations would happen on NVIDIA GPU platform, which frankly is the de facto AI platform today when it comes to training and fine-tuning. And once that model is fine-tuned, you can then bring it on to the NPU built into our silicon. And what this really does is allows you a very strong starting point, and it allows you to leverage the tremendous investment NVIDIA has made in the field of AI, but then brings all those benefits onto a MediaTek SoC. So I would encourage you to download and use the NVIDIA TAO toolkit in conjunction with our SDK. This is probably in some ways the most exciting development this year. We have decided to bring a lot of our information for the developers online. So we have a dedicated Genio developer portal. The URL is listed there. I would encourage you to click on it, look at the content there, give us feedback, tell us what you found useful, tell us what we can do better. We've got detailed product information, the software, all the documentation on how to use it, design with our SoCs, the hardware design support, the EVKs, and the associated boards. We'll also keep adding more blocks as we find more ecosystem partners are designing solutions. We're going to talk about both their experience of designing with MediaTek SoCs, but also some of the more exciting, general advancements in the areas of IoT. So I would watch out for new blogs, and these will vary from, focusing on AI, looking at the next generation of RedCap connectivity, things like that. We are also very excited to open up a community portal where we expect our developers, our engineers, to interact and to learn from each other, including best practices. So I would request you to go to this portal. As I said earlier, please look at it, give us feedback. Let's now look at a couple of real-life customer examples. VIA Technologies used our Genio 700 SoC to enhance factory floor safety. And really what they were doing here is using AI-powered gear inspections. So, advanced camera capabilities, the built-in deep learning accelerator, all the flexible I/O options that we provide, both for input and for output, for high definition video, for HDMI. All this helped them design a very effective AI-driven safety monitoring device. So thanks to our partners, VIA Technologies. And the second example is from a partner, Xcheng in China, who are using our Genio 1200 SoC for a smart industrial device. And really, the reason they chose us was between the octa-core that gives them advanced processing for real-time processing, including camera analytics, industrial-grade environment, temperature support, comprehensive connectivity, and all resulted in a very cost-effective deployment of this capability in a manufacturing setup. So thanks to our partner, Xcheng, and we hope to do more. And I shared these two examples because, as you can see, we've been historically very successful in consumer adjacent markets, but increasingly we are finding our customers leveraging the Genio and our SoC capabilities into markets that are a bit more ruggedized, have higher temp requirements, and in general have much more robust operating environment and needs. So in conclusion, I know I covered a lot of the content today. We firmly believe that AI, not just legacy analytical AI, but also Gen AI applications will be driving a lot of the refresh and demand in IoT and embedded space. Our new SoCs with integrated NPU capabilities, optimized not just at the hardware level, but also with the software offering and with the ecosystem partners are going to be critical. The ability to personalize using AI, to have more tailored user experiences, especially more natural language processing based on interaction, will drive a lot more adoption. We do expect a much deeper integration of capabilities like 5G, where it's needed, fully needed, or red cap version of it, where the full bandwidth is not needed. Advanced Wi-Fi capabilities for lower latency and higher speed transmission. And I think the focus on sustainability will continue to be a topic. The amount of gigapowers of and the powered installations that are now required to power our data centers are going to are going to result in a much sharper focus on how more processing at the edge is going to be a requirement in the future, not just an option. In summary, I want to thank you for joining us. I look forward to you answering your questions, but more importantly, I'm hoping today is the start of a journey where we see a lot more interaction with the content and the SoC that we provide, and our developers who ultimately are customers, and our developers who are ultimately the real path to success for us, because when they succeed, we succeed. Thank you very much.
All right. Well, thanks, Samir, for that really detailed presentation. It really struck me early on that you mentioned that MediaTek provides a 10-year guaranteed access to your products. And that is so important for many of those edge applications, particularly like those industrial ones you shared at the end. So we've got a lot of interesting questions already, but I want to let the audience know there's still time to submit your questions. So Samir, you ready to answer some of these questions?
Let's go, Dale. This is why I'm here.
Awesome. So first one is, how does MediaTek integrate AI capabilities across edge devices and cloud infrastructure?
Yeah. So I'm going to dissect this question, and there's a multi-layered answer to this, right? If you think about the evolution of the hardware and software that's required for AI, some of the classic use cases were initially implemented on CPU. Then GPU became the architecture of choice, especially for training, right? NVIDIA has done a fantastic job